Hello, welcome to Topper Machine. I'm Josh Topper. So I got this one in, just came in, emergency rush job for a customer. It is a idler wheel off of a big horizontal bandsaw, metal cutting bandsaw. They do a lot of large capacity stuff, and it's down because the bearing locked up and wobbled out the hole. So we're going to get this up on the Bridgeport, and we're going to do it on there because the horizontal boring mill is actually set up for a line boring job right now. So I got to do this on what I can do it on quickly, and that'll be the Bridgeport with a boring head. And I have an interesting boring head, so you get to see that one. And I'll show you how to indicate for center with a center indicating tool that I have that works really well. I've used it a lot on steam engine stuff. Works great. Now, this job is an emergency rush job because it's 2:40 in the afternoon on Thursday. Friday, tomorrow, I'm leaving on vacation for a week. Tomorrow morning. So we got to get this done and get it out of here. So let's get this up in the mill and let's get going. Okay, so I got this beast up here in the Bridgeport. Wasn't easy. We had to move the ram out to get the travel we needed. And I got this centering indicator in here. This thing's pretty cool. I'll move you in and show you. But you basically just turn your spindle, and it's got a little feeler arm on it, and the thing works incredibly well for what it is. So it's pretty close right now. We'll just get the fine tuning done, and then we'll start set up and bore. So I'll move you in and show you the indicator. So this is a very inexpensive little unit, and it just rotates in your spindle, and there's multiple of these feeler arms, but the thing works great, and they're very inexpensive. I think this was like $60. Money well spent. I've used this thing quite a bit in the last year. I've had it about a year, well, maybe a little longer than that, and it's just been a good investment. So now we got our bore lined up. We're zeroed on our digital readout. Now I'm going to go get the boring head and get that in here, and then we'll find some material that'll work for this. Okay, this is what I have for a boring head. This is a boring and facing head. It's an R8. It actually clamps over the quill, but it's a facing head, so you turn the crank and it adjusts the boring bar. Much nicer than a standard boring head. I did find a name on this at one point. I don't know where it is now, but I looked when I came across this thing years ago. I nabbed it up right away because it was so handy. And I have a very similar setup, a boring and facing head for the boring mill too, but these are awesome. If you come across one of these, they're worth the money. So we're going to get this on there and we'll start boring. So we're all set up. I already touched off. I went in 150, or I went in 1 inch, 500 thousandths. Sorry, my brain's not working right. It's 100 degrees this week here, and my air conditioner crapped out on Tuesday, and I am just drenched in sweat and tired and hot, and so we're gonna bore this out to like 4 1/4. It's 3 15/16 is the finished diameter, so we'll bore it out to 4 1/4, make a bushing, push it in, and then we'll see what we got to do from there. But we're going to go 1.5 inches deep to start with, and I set our stop here. I'm having some issues with this. I'm going to have to manually reset it each time so it kicks out on its own, but not a big deal. So let's get started. Okay, we got the boring and the pulley done, or the drive wheel. And I just threw this chunk up here. This is 4 3/4, 1018 cold rolled round, and drilled through it. I'm gonna rough it out close to size, and then cool it. So let it cool, and then we'll do the final passes, clean it up, and we're gonna make a 1 thou press fit. And then we're gonna try to go for the bearing fit. We're gonna try to go maybe less than that even. We're gonna try to get it so close that it's, I mean, we got to get it as close as possible so it won't spin in there, but we won't create too much pressure on the bearing. So I'm going to go ahead and start roughing this out and get it close to size, and then we'll let it cool. All right, this is the point where I stop. I'm within about 50 thou OD and ID, and this thing's hot, like very hot. We're gonna let it cool. Not gonna take it out of the chuck, gonna just leave it here, let it cool, and we're gonna go have dinner or something and come back to it, and then we'll finish it off, but we're gonna keep it cold the whole time we're finishing it. We're gonna use ice, whatever. I don't want the material to expand. I want to be as close as I can, and we may have to just polish it down to final size. Now, you guys probably saw it earlier. Right there is a new blade for the sawmill. 52-inch, 32-tooth, left hand, 500 RPM hammered, ready to go. One of these days here soon, we'll do that video when we put that on and show setting that up. But so make sure you subscribe if you aren't already. And check out our sawmill videos. So we'll be back to this shortly, and I'm gonna go cool off in the house for a while. All right, so we're back. Part wasn't fully cool, so I put some ice in there and got her down nice and cold. And it, I need the outside diameter. The bore on that pulley is 4.185. I want to be 4.1855 or 4.186. So right now, .03 2.031. Actually, we're a little less than 1. We're 0.306. So we're going to start by taking about 25 thousandths off. We'll just whittle this down. We're going to get it close. I'll probably finish it with emery cloth, and then we'll work on the bore. there is our bushing. And if I know what the hell I'm doing, which maybe, that should go in there fairly smoothly. It's a little tight. Worst case, as close as I got this thing, worst case, might have to use a cylinder hone on it, but it should tap right in. So let's grab a hammer and find out. Well, there you have it. It's all together, and I am beat. I am drenched in sweat with that air conditioner being down. It's like 90 degrees in here. This was the most brutal job I've done in a long time. Just miserable with that air down. But we got it. As you saw, very difficult to hit your sizes. You got to keep it cool. Keep your, take your time. Keep your cool. And when I got it all together, it's a little bit tighter on the bore than I wanted. It's hard to hit those sizes when you're trying to do two sizes where you're trying to hit it perfect, to get it perfect. But as it is, I'm 1/1000th smaller than what I wanted. So a little bit of time with the cylinder hone will clean that right up. Should be just fine. And the customer can get this back in the saw and get going. And that's one of the most important aspects to being a manual machine shop, being a shop in general. Taking on jobs like this, emergency jobs, rush jobs, things you wouldn't normally do. I would normally do this in a lathe, but I don't have a lathe big enough to swing this. So this is the best way to do this, other than the horizontal boring mill, which would have been better. But this went well, and you guys can do this kind of stuff too. It just takes a little time, a little setup. But you got to think it through and just take your time on stuff like this, and you can do it. It's pretty easy. So with that, I'm going on vacation starting tomorrow. Hopefully no more emergency jobs. This was the second emergency job today. Just wow. What a day. So we're going on vacation to South Dakota. I might bring the camera with. I haven't decided yet. We'll see how that goes. And just got to get out of here for a few days and clear my mind. Or a week. So you can check out my website, www.toppermachine.com. And please like, subscribe, and share. Stay with us and see what other cool emergency jobs we get. Because, this one was pretty cool. I actually enjoyed doing this, even though I'm just dying. Just get out in your shop and get it done right the first time.